My name is Huining Zhao. Today we're talking about functions 11. Chapter 1, quadratic function. The topic is exploring transformation to quadratic function using Geogebra. Concepts. The standard form gx equal a f k bracket x minus d and brackets plus c by applying the appropriate transformation from the parent function y equals fx and making sure to apply a and k before c and d. When using transformation to graph, you can apply a and k together, then c and d together. The values of a and k change the shape, but the values of d and c change the position. Step by step. For a, it determines the vertical stretch or compression and whether there is a refraction in the x-axis. For k, it determines the horizontal stretch or compression and whether there is a refraction in the y-axis. For d, it determines the horizontal translation. If d more than 0, the graph is translated d unit right. But if d less than 0, the graph is translated d units left. For c, it determines the vertical translation. If c more than 0, the graph is translated c unit up. If c less than 0, the graph is translated c units down. Next, we're talking about in details about a and k. The value of a determines the horizontal stretch or compression and whether there is the refraction in the x-axis. And when absolute a more than 1, the graph is stretched vertical by the factor absolute a. And when absolute a less than 1, the graph is compressed vertical by the factor absolute a. When a less than 0, the graph is reflected in the x-axis. Number 2, the value of k determines the horizontal stretch or compression and whether there is a refraction in the y-axis. When absolute k more than 1, the graph is compressed horizontally by factor absolute 1 over k. When absolute k less than 1, the graph is charged horizontally by the factor absolute 1 over k. When k less than 0, the graph is reflected in the y-axis. For example, let the parent function is fx equal x squared. The first one change a. Let the gx equal a times x squared. Secondary, change k. Set the edge x equal bracket k times x bracket square. Change d. The px equal the perfect square of x minus d. And last one, change c. And the Lx equal x squared plus c. So now we change to Geogebra to explain how about the transformation. we can see we use the Geogebra. The parallel function fs equals s squared. So we can see this one, the green one. And here we found the change a. So we said the function is two x squared. So we can see the new function here inside one. Because a is 2, so it's more than 1. That means it's charged horizontal by a factor of 2. What does it mean? We can draw a line, a vertical line, like the x equal 1. So we can compare two graph. After transformation, this y value is greater than the fs, that means the parent function. Alright, so this means it's charged vertically. And now I want to set up another function as changeable, like a x squared here. And here, a can change a. Here. From negative, we can see this negative one, the negative 1.6 here. So the opening down because a is negative. So that means it's a reflection axis. And change a go to positive, like the 0.4 is less than 1. So that means it's lower the parent function. That means this compression vertically by a factor of 0.4. When continue to change to 1.4, 1.8, 4. So here we hide that one here. So we can see the edge is I draw a vertical line, x equal like 1. So we can compare here to graph. After the transformation, under the same x value is greater than the parent function. That means hx greater than the fs. This charge vertically by a factor of 4. Okay. Next, we are going to change k. So delete that. Don't confuse. Okay. And I put another function like the 2 x squared. So here k is 2. That means 1 over 2 is 0.5. This 0.5 is less than 1. So we can see this edge, this p. This one is p. So when 1 over k is less than 1, that means it is compression horizontal by a factor of 0.5 here. And what does it mean? We draw a horizontal line. You can see that line y equal 2. So in the direction of horizontal, in the same y value, we can see the p, the x value is less than parent function, right? So that means is compression, because it is less than the parent function, right? So next we are going to set up another function like the arrow x is changeable function equal like a k here x at the square, so here change see the k here. When k is negative like that, so we want to hide p. Okay, like the k is negative one, so it's reflect with the y-axis, because this graph is symmetrical with the y-axis, so we cannot see any change. And change this one to the negative positive here, and here k is we said 0.5. What is mean? What has happened? I want to see. Okay, this here. So we can see the red one. When k is 0.5, that means 1 over k is 1 over 0.5. This is more than 1. So that means it's charge. That means it's increase. The charge horizontal by a factor of 1 over 0.5, that means it's 2. So under the same y value, we can see the x compare the x value. For after transformation, the x value is more than the parent function, the x value. So that means it's charged in horizontal direction. So change k like this one, it's more than 1, like 2.2. 2.3 here. So we can see that under the same y value, the after transformation, the x value is less than the parent function. So that means it's compression. If k is 2.3, that means it is compression horizontal by a factor of 2.3. That means it's less than under the same y, the x value increase from the parent function, right? So okay, next we're talking about the change the d. So we're going to delete. No confused. Okay, delete that one. We set another function like the p x equal x minus 1 square 2. So delete that line. Okay, so we can see here d is 1, so all the graph move right side 1 unit, because d is positive 1. So next we're going to set up another function is changeable, like the x minus d the square. So d is changed. Okay, we hide that one. So we can change the d from negative, negative, negative here -5. Here, that means the graph move left side 5 units and move D, and here when D is 0 and same, and then move the right side, the D is 2.1, and then 2.5, 3 here. So the graph moved the right side 3 units from the parent function. Okay, and next we're going to change C. So I want to delete that. I'm confused. And we're going to input another function like x square plus 2 here. Okay, here that means the graph move 2 units up, because here it sees 2. Okay, and next I'm going to input this one, x square plus c. Here c, we can change c, and I want to hide that p. So we can see this one, the c. Here the c is 1, so it's hold the graph move up 1 unit. And then if the c is negative, so the negative 3.2, so that means move down the 3.2 unit, and then change up to c is 2.5, so move up 2.5 unit, right? So we can see the AKDC. A and K can change the shape of the graph, and the D and C change the position, right? So next we're going to input other function, like, let me see here, let the g x go -4 and x -1 and square, equal to square, and then plus like 3 here. So the A is -4 and K is 1, C is 3, and D is 1. So we can see this is the critical point and the special point here. Okay, they are the root A and B, that means 0. A is about 0.1339, and B is about 1.866, blah blah blah. And then the actual, like here is the maximum point is 1,3, because the A is negative, so it is opening down. It have the maximum point, right? The maximum value is 3, and the intersection with the y-axis is the -1. So this is the graph here. From change AKDC and using the Geogebra, we can see the different situation. So right now we finish this topic. Thank you. Thank you for your listening. Please subscribe my channel. Thank you. See you next time.